So composite functions are a way to combine two functions. So this is said. So what this means, f of g of x means f of g of x. In other words, g of x is the input into f, is what that's saying. G of x is the input of f. And if it's the other way around, g of f of x, then f of x is the input into g. Okay, I like to introduce this actually with table of values first. So I'm going to do the table of values, and then I'm going to come back to this first example. So if you jump to your last page here, let's do some of these table of values first, and then we'll come back. Okay, so this says f, remember f of, what's going on? So f of g of x means f of g of x. So if you notice for this one, we have f of g of 1. So what we're going to do is, number one, we're going to find what's g of 1. So when we look on the table, I find g. Okay, here's g. If x is 1, g of 1 would be 0, right? So g of 1 is 0. So now I go back to that, and I say, oh, well, if g of 1 is 0, number 2, what's f of 0? So now I look at f of x. Here's f of x. F of 0, 0 goes in. F of 0 is what? 5. In other words, f of g of 1 is 5. Make sense? Let's do another one. F, notice the next one. F of g of 2. F of g of 2. So let's do g of 2 first. Number one, what's g of 2? Find what the inside value is. What's g of 2 from the table? What's that? Good, yep. Here's our g function. If x is 2, g of 2 is negative 3. Good. So now we say, okay, what's f of negative 3? So number 2, what's f of negative 3 then? Good. Yep. Here's an f function. If negative 3 is the input, f of negative 3 is 11. So in other words, f of g of 2 equals 11. Now let's go g of f of 2. G of f of 2. Let me erase these. Okay, g of f of 2. Okay, so number one, we're going to find what's f of 2. What's f of 2? So I'm going to go up here, look at my f function. What's f of 2? Good, yep, 1. So now we're finding g of 1, right? So now we go back up, okay, g of 1 is 0. So in other words, g of f of 2 is 0. How about g of 1? G of 1. So let's find g of 1. Let's go back up. What's our g of 1? Good, g of 1 is 0, yep. So g of 0 is, go back up, g of 0, 1. Yep. In other words, g of 1 is 1. Lastly, f of 3. So let's find f of 3. F of 3 is -1. Yep, so let's come back down. Now we're finding f of -1. Go back up, f of -1, 7. Good. In other words, f of 3 is 7 is what we're saying. All right, so let's go back up. Now that we've done it with the table of values, and it would be similarly with if you had a graphs as well. You just find the value on the graph and then go to the other graph, find the value, and so on, or whatever graph it's telling you to look at. Okay, let's go back up here now, and let's do it with the functions. So we have f of, all right, so we got f of g of 2, and we got f of g, which means f of g of 2, right? So I go ahead and wrote what it means. So I'm going to go to the side, I'm going to find out what's g of 2. Well, I know g of x in the instructions here is 3x plus 1. So g of 2 would be what? 7, right? Yeah, we got 7. So that's 7. So now I'm finding f of 7. So I'm like, well, what's f of x? 5x minus 4. So what's f of 7? So it's 5x minus 4, right? And we're just throwing the 7 in. I'm just showing you it over here. 35 minus 4, so 31. In other words, f of g of 2 is 31. Let's do g of f of -1. G of f of -1. So I'm going to go to the side. I'm going to do, I know f of x is 5x minus 4. So f of -1, -5 minus 4, -9. And now I say, well, g of -9 then, I know g of x is 3x plus 1, so g of -9. So 3x plus 1. Again, -9 goes in. F of -1 goes in, which is -9. So we got -27 plus 1. So we got -26. G of -9. So in other words, g of f of -1, -26. All right, so now we got f of g of x. So we're doing this without values for x now. So I'm going to write this, f of g of x. So let me go to the side. What's my g of x? Well, g of x is 3x plus 1, right? So this is the same as f of 3x plus 1. And now I know f of x is 5x minus 4, right? It's 5x minus 4. But my g is going in there. It's going in for x. So 5, instead of 5x, it's 5, g is going in. Well, g is 3x plus 1. 5 times 3x plus 1. And now we just finish it off. 15x plus 5 minus 4. 15x plus 1. So that's what f of g of x is. It's 15x plus 1. And remember on the very first one we found f of g of 2 and it was 31. See this one up here, f of g of 2 is 31. So look at this. You could find, now that you have f of g of x, so f of g of 2, 15 times 2 plus 1. Hey, look at that, 31. See, that's the same thing. Now the next one we're going to be asked to do g of f of x. So g of f of x. So we have g of f of x. So g of, and our f of x is 5x minus 4, right? Note, f of x is 5x minus 4. And our g of x is 3x plus 1. So this is, now the f is going into g. So I got to use g. G is 3x plus 1. Remember, f is going in. F is 5x minus 4. So this just ends up being 15x minus 12 plus 1 minus 11. So that's g of f of x is 15x minus 11. And notice on our second one, it was asking us, what's g of f of negative 1? All right, it asked us g of f of negative 1. That was negative 26, wasn't it? So same thing. Right? We have g of f of x, so I could find g of f of whatever if I wanted to. All right, a couple more. We got f of x is f of x now. F of x. So f of x. And note, f of x was 5x minus 4. So this is f of 5x minus 4. So 5x minus 4 is going into f. Well, f is 5x minus 4. But we're replacing the x with f. F goes into f. So we have 25x minus 20 minus 4. 25x minus 24 is f of x. Let's do this next one, g of x. G of x was 3x plus 1. So this is g of 3x plus 1. Well, g is 3x plus 1, but g's going in. G's going into g. So we got 9x plus 3 plus 1. So we got 9x plus 4. That's g of x. These ones would not be these ones would be a pretty good you try. So if you want to pause it right here and go ahead and try that first one, we'll go through that. All right, guys, go ahead and check yourself with that. So I went to the side, I found g of x, or g of negative 1, which ended up being 1. I threw that in right there. So now I'm finding f of 1. Well, f of x is x plus 3, so I just got to throw the 1 in. 1 plus 3, and I end up with 4 on that. Let's do this. Let's do this next one too. This one is g of f of 0. So I'm going to go to the side. Well, I know f of x is x plus 3, so f of 0 would be 3. So I have g of 3, right? So now I'm using g of x. Well, g of x is 2x squared minus 1, so I'm just finding g of 3 on this. So I have 2x squared minus 1. F of 0 goes in. F of 0 is 3. So 2 times 3 squared. Well, 3 squared is 9. 2 times 9, 18. Minus 1, I got 17 on this. So g of f of 0 ends up being 17. So let's do it without variables now. F of g of x. F of g of x. So I say, well, what's g of x? G of x was 2x squared minus 1. So I'm using f. I'm using f now. I know f is x plus 3, and that g goes in. Here's my g going in for x. So we end up with 2x squared minus 1 plus 3. Well, that's plus 2. So there's f of g of x. And notice if I was finding f of g of negative 1, it would spit out that 4 that we got on that first one, on part A. Right? I'd have negative 1 squared is 1. 2 times 1 is 2. 2 plus 2 is 4. So it gives us part A, right? All right, let's do g of f of x. G of f of x. G of f of x. G of, I say, well, f of x is x plus 3. And now I'm using g. Well, g is 2x squared minus 1, if you remember g. G is 2x squared minus 1. But f is going in, so that x plus 3 has got to go in. So I got 2x plus 3 quantity squared. So I'm going to have to expand that. So it's x squared plus 3x plus 3x plus 9. So distribute the 2x squared plus 12x plus 18 minus 1. So, well, 18 minus 1 is just a 17 on the end. So there's our g of f of x. 2x squared plus 12x plus 17. A couple more here. F of x. F of x. So that's f of, remember our f of x is x plus 3. So now we're using f. F is x plus 3. But f is going in. This is f of x. F is going in, so x plus 3 plus 3, which is just x plus 6. So f of x is x plus 6. G of x. G of x. So that's g of, remember our red g of x is 2x squared minus 1. So this becomes g is going into g. Well, g is 2x squared minus 1. And g's got to go in for x. Make sure to expand this. Minus 2x squared, that's minus 4x squared plus 1. Distribute the 2. Bless you. So g of x ends up being 8x to the 4th minus 8x squared plus 1. You could make these a u-try if you'd like to, but we're going to go ahead and find f of g of 0. So f of g of 0. So let's go to the side. I know g of x is negative 1 over x. So what would g of 0 be? Can I divide by 0? No, that's undefined. So this is undefined. Okay. Because 0 is not in the domain for g, so it's not in the domain of f of g of x either. About f of g of x. F of g of x. Well, let's see. Our g is negative 1 over x. And now we're using f. F is 4 minus x squared. F is 4 minus x squared. So the g goes in there. The negative 1 over x goes in there. So we got, this is 4 minus, I got negative 1 over x times another negative 1 over x. So multiplying those numerators, negative 1 times negative 1 is positive 1 over x squared. And notice it did ask us to express it as single fractions in factored form, if possible. So this is over 1. Let's get it a common denominator of x squared. So this is 4x squared minus 1 all over x squared. So f of g of x, and I can factor that. That's 2x minus 1, 2x plus 1 all over x squared. And notice, by the way, x can't be 0, right? X can't be 0. And we know it from right here as well. X can't be 0. Right? That'll not be in our domain here. the domain here would be from negative infinity up to 0, and then I'd take off from 0, right? So everything but 0 is in my domain. Let's do some more here. How about g of f of x? So g of, and our, let's see, our f of x, what was our f of x again? 4 minus x squared. So 4 minus x squared goes into g. G is negative 1 over x. Put that f in. So 4 minus x squared. And then we'll just clean this up. This is negative 1 over, and I'm going to actually take a negative out of these. So I have negative 4 plus x squared changes those signs. So negative over a negative is a positive. So it's 1 over negative 4 plus x squared. In other words, x squared minus 4. So g of f of x is 1 over x minus 2, x plus 2. And notice you can't have 2 or negative 2 in your domain on this, can you? Can't divide by 2 or negative 2, because it would cause us to divide by 0. Right? All right, a couple more and then we'll move on. F of x. F of f of x. F of x. Well, that's f of, if you remember, f of x is 4 minus x squared. So 4 minus x squared is going into f. F is 4 minus x squared. Put f in to f. I'm going to go ahead and multiply that out. 4 minus x squared times another 4 minus x squared. So I got 16 minus 4x squared minus 4x squared is minus 8x squared. Negative x squared times negative x squared is plus x to the 4th. Distribute this. Combine like terms. That'll be a negative x to the 4th plus an 8x squared. Negative 16 plus 4 is negative 12. So that's f of x. Negative x to the 4th plus 8x squared minus 12. And finally our last one, g of x. G of x. Remember, g of x is negative 1 over x. So g goes into g. Well, g is negative 1 over x. But g goes in. So that's negative 1 over x. And I actually want to pause before I clean this up right here. This is the best point to actually analyze what x cannot be. X cannot be 0. Because notice what happens. I have a negative over a negative 1 over x. Well, a negative over negative is positive. Now I'm going to multiply by the reciprocal. This actually cleans up to just be x. So g of x is x. So if you hadn't picked it up right here, you wouldn't have known that the domain can't be 0 because g of x is not defined as 0. So the domain on this is everything but 0. Everything but 0. Or you can also write it this way. X such that x is an element of the reals. It just can't be 0. All right? Again, as soon as you plug it in, take a look at it at that point. And we'll do some more with this, by the way, with these domain and ranges. So let's do one here with this domain and range, and I'll kind of show you another example of that. So f of x, I'm trying to find f of g of x here. So I have f of, and my g of x on this one is 1 over x. So 1 over x going into f. All right, our f is 5 over x minus 3. Put the g in. And right here, I want you to pause and I want you to say, okay, what can x not be? Right there. Can't be 0. Yeah, so make a note of that. Domain, so far, I know it can't be 0. Now let's clean it up and see if there's anything else I got to toss out. So I have 5 over 1 over x minus 3. Get a common denominator here of x. So I have 5 over 1 minus 3x all over x. Now I'm going to multiply by the reciprocal. So x over 1 minus 3x, top and bottom there. So my f of g of x ends up being 5x over 1 minus 3x. Now, I'm also looking right there as well. I know 1 minus 3x can't be 0. This will be a problem. So 1 divide by 3 divide by 3. So x can't be 1/3 either. I got to add that to my domain. It can't be 1/3 either. That'll give me all kinds of issues, right? So this is f of g of x, 5x over 1 minus 3x. I am done. I found that. But just note my domain is everything except for 0 and 1/3. It can't be either of those. So I had to pick it up right here at the beginning and at the end right there as well. Right? So right when you plug it in, take a look at it first for your domain, and then at the end as well if you need to as well. So another way to do this, negative infinity up to 0, and then from 0 to 1/3, and then from 1/3 on. Right? That's another way to do that domain on that. All right, these last two are just saying, hey, can you go from the actual composite function backwards to f and g? So can you figure out f, what's g? Well, what we have is, this is how I think about it. I'm like, hey, one way to think about it, what's on the inside? Oh, my g of x is going to be, this is one of my answers. By the way, there is more than one solution to this. G of x could be 1 plus x squared. Well, if g of x is 1 plus x squared, who's f of x? You'd say it'd be that cubed. Right? And you could check it. That would give it to you. By the way, that's not the only one. You could also let g of x be x squared, and f of x would be 1 plus x quantity cubed. That's another one. You could also let g of x be x, and f of x is just 1 plus x squared quantity cubed. So there's 3 different ones that are pretty reasonable to pick out, but this is maybe one that you look at, right? And you could always check it, right? If you check it and you're like, well, what's f of g of x? And you'd find it. You say, well, f of x I'm claiming to be x cubed. G's going in. Is that what we had? Oh, yeah, that's it. So this sure enough does work, right? All right, how about this one? This one might be a little bit harder to see. What's f of g of x? Square root 2x minus 1. And look at this minus 4x plus 2. Maybe it'd be easier if I took out a minus 2. Look what I have here. See how that's still negative 4x plus 2? So what I'm seeing is I'm like, oh, I see those. I have those 2x minus 1s. That's what I'm going to make. I'm going to make g of x be my 2x minus 1. If that's my 2x minus 1, right, then f of x would be square root 2x minus 1, x, minus 2, 2x minus 1. Right, so it would be square root x minus 2x. Those would be my 2 that would work for this. Again, you could check f of g of x and make sure that it puts it back and gives you that original function. Well, the next part is actually our tables. We already did the tables. That was what I used to introduce it. So I'm going to stop it right there. Thanks so much for watching.